Let's talk about test data generation. Now, while unit tests often include their own data inside the test to ensure consistency, other tests typically need a larger set of test data, but a known set of test data that's loaded into the database. Performance tests certainly want a known size of data to ensure that they're a valid test for production. Again, often production are larger than production size data. When we talk about generating test data, we really have two ways of doing this. We can use a known set of data like production data, or we could kind of use random data. Ideally, most organizations want to use that production data, but there's plenty of reasons why this isn't a good idea. We've covered a few of them in other modules, but the big reasons are the issues with regard to production data are that it's large, right, and it's secure, and that's an issue. But let's talk about the different issues for test data and how each of them might examine to using production or randomly generated data. The first one is the realistic size of data. Now, developers often want production data because they want all the data in production that they'll have to deal with. It mimics what their application will see, the size, not only the size, but what rows, what different cases are in there. Too often, issues in production are masked because we don't use enough test data. We don't have enough cases, or we don't have enough data itself for the developers to actually build queries or interact with the database appropriately. Modern query engines they're amazing. They perform really well, but they can struggle with large data sets and poor code. Now, generating large amounts of data is cumbersome, and there's not a lot of tools that are available to help. There's a few out there, but typically they're difficult to work with, and they require some effort to build that data. If developers have to build the data themselves, randomly generate things, it's very tedious. So production restores are relatively easy to perform. That's simple. The downside is if I'm always going to use a large set of data, then I've got to deal with that large set of data. If I run test queries that are poorly written or that do cross joins, they're going to be very, very slow. Making a mistake in development means that I might end up just waiting a long time for queries to run, and that slows down developers. That's not something we want. Even when developers are careful, large data sets are hard to check for accuracy. If I'm trying to do a complex sum calculation, such as a running total or calculate the sum of islands, do I want to do that across 2 or 3 or 4 accounts, or do I want to do it across 50,000 accounts? For efficient development, I want to do it against the former, just a few accounts. At some point, I want to do it against 50,000, but that's different. The other problem with large data sets, whether they're from production or generated, is that they're cumbersome. They're hard to move around. They take a lot of space. 1 terabyte database is going to overwhelm most developer hardware, such as our laptops. It takes lots of time to copy around. It slows down the entire system. It starts up slowly, and if I make a mistake, it's difficult to deal with again. We typically want to leave large data sets for performance testing and only run those when other tests are complete. So we need some smaller data sets that we're going to use in other areas. The skew of data is another issue we have to think about. A skew is what's my distribution of values. For example, how many A's, B's, C's do I have in a list of names? The generation you may have in your database or the distribution will be different than it is in other areas. And so using production data means I have the exact distribution I'll see in production. If I have things like account balances, I'll have things in the proper range, right? Accounts will be thousands of dollars or millions of dollars or whatever range is appropriate for my system. We also have the bad data in production that users manage to slip in the system or we haven't accounted for. So production data is very helpful in mimicking the skew that developers want to see. Data generation programs, custom scripts, they typically have struggled here. I don't know of any systems that will actually generate data based on a skew in production. It doesn't matter whether that's numeric values, string values, or something else. What's also harder to do is ensure that I have the correct number of records distributed for each area. So do I have the same average number of child records for parent records? That's difficult to do in generation situations. Production data is better here because it's got all that information. It has the average number of child records. The one place that production fails, production doesn't have the values that may come about in the future that we don't know about. There are always unknown data values that might occur in a database, and we never test for those things because production doesn't have those values in there. For example, in an ordering system, we might never assume a negative quantity for a price. We might think that if we were going to return something, we'd have a negative quantity of purchase, not a negative price. At some point, though, we may have a user that enters a negative price and breaks the application. We don't want that to happen. We want to have tested for that early on. Production data would never have that case because it hasn't occurred, but generated data would, because users, developers, they would actually think about what might somebody do, what's strange. Another example might be Unicode data. Developer might never think to test different languages or something like Kana sensitivity for reports because they don't have any Japanese data now. But if we're going to deploy our system to Japan, we've got to test for it. Custom scripts and generators are helpful here because we can tell them, produce random data that fits a corner case, produce random data that is in the Japanese language, so that we can test for those things. This is especially true of null values, which developers don't often consider, somehow sneak into the system. So generators, while not perfect, they certainly provide us a better set of data to work with when we consider all the possible values that might be there. Another issue you have to think about is data privacy or data security. The biggest downside to using production data is that it's real data, which could be sensitive data. We have personally identifiable data, medical data, financial data, something else. More and more industries are finding themselves regulated by the government or dealing with regulatory issues that actually prevent developers from accessing this data. Even less secure systems such as QA might not be able to use this data. That means that we have to be really careful, especially if it's data we don't even think about, like innocuous data like email addresses. There's no shortage of cases where developers have made a mistake with this kind of data, such as accidentally emailing a customer from development when they're testing the system. Or maybe they email all customers because they didn't obfuscate or change email addresses. Generated data often has none of these issues and is preferred to production data, but certainly we could take production data and mask it and change it. We just have to include that as part of our process. The other thing we'd like to do is have a known baseline of things. When developers want production data, what they really want is a known baseline, right? If they have any question about the calculations for a set of accounts or the value of a portfolio, they have the real data, and if they show it to a business user or a customer, it makes sense to that customer. They expect to see certain values there, and they can tell you if the application is working correctly. Having lots of data doesn't make any sense if it doesn't make any sense to any of our users. If I can't show it to a tester or to a QA person and have them understand the data, it becomes less valuable to me. If the data can be changed to any random value, it requires some work to get there. The best solution for long-term database development is to have a curated set of test data that has not only enough size and scale, also the correct SKU, and it has different permutations of values that allow us to accurately test the limits of our code. We want to ensure we have some random values that might not appear in production, some cases that might not appear, but we want to ensure we have some other test sets that are similar to what's in production. We have to maintain this as the database evolves for sure, but this also means that any new developer, any new environment, such as test or staging or UAT, can quickly and easily be created on demand. In this age today of rapid development, of constant branching and short-lived branching, parallelization of our efforts with containers and virtual machines, having a good set of test data is very, very important. Typically, the way we would curate a set of test data is we'll start with production. And we'll remove most of the data, but we'll keep some representative sets. There may be 5 customers that really explain how the system works. And so we keep those. And then we add random data to this. And as we discover new test cases, as bugs are reported, we add new test data to cover that situation. We adjust our data set, and certainly we evolve it as we evolve the database schema. I have a customer that does this. They work in multiple countries, and so they have different sets of localized test data for each country, and they evolve it over time, and it's resulted in much, much more accurate testing, many, many more deployments, very few rollbacks, and very few bugs to their customers. Having a good quality set of test data you store in version control and you use to build all your environments on demand is a great way to improve your DevOps development process.